Hi, my name is Lisa Pearl, and I'm an associate professor at UCIrvine in the departments of linguistics and cognitive sciences, and I run the Computational Language Laboratory. And one of the things we really like to do is use computational modeling to understand language acquisition. So that's what I want to talk to you about today. So first of all, what is language acquisition? Well, what it is how humans learn language knowledge, all the stuff that you know about your language that you speak. And so there's first two distinctions. One is first language acquisition. This is when you're learning your native language, or native languages if you're a multilingual speaker, and it happens when you're a young child. Now, the second kind is second language acquisition. And this is the kind of acquisition that happens usually in a school setting when you're older, when you're an adult. It's much more rigorous, it's much more structured, and you usually don't end up with native level knowledge at the end. So in my lab, we really concentrate on first language acquisition. And the question we ask is, how is it that really young children acquire the knowledge about language that they do from the language data that they encounter? So what you might be wondering is, what is so interesting about that? Why first language acquisition? Well, let me tell you. The answer is that babies are amazing at learning language, right? And in fact, they learn a lot of different stuff about language. And so you might think, well, like what? And the answer is everything that you know about your native language or languages is what you learned as a very young child. So what I want to do now is give you some examples of the kinds of things that you already know how to do for your native language. One of the things you know is how to identify words in a fluent stream of speech, which is called speech segmentation. And so what this is taking a continuous stream of auditory signal, which is in fact what you experience when you don't know anything about a language. The first time you hear it, it's just a stream of sound. And that's because in reality, it is just a stream of sound, right? It's what this visual representation of that auditory signal is. But that's not how you experience it. You internalize it into some symbolic representation, which you consciously experience as the phrase, say, like, what a pretty kitty, right? A sequence of words that you recognize. And that's the process of speech segmentation, which you know how to do. You also know how to pronounce words using your knowledge of metrical phonology. That's where the emphasis or the stress is in the pronunciation. So the word kitty, it has stress on the first syllable. It's kitty, right? And if you pronounce it kitty, that's a completely different word. That's wrong, right? So this is, again, part of your knowledge that you have about pronunciation for your native language, which is the knowledge of metrical phonology. You also know that certain words behave like other words. And what do I mean by that? So if you take the phrase, what a pretty blank, right? What kind of words can go in there? Well, you can say, what a pretty penguin, what a pretty kitty, what a pretty owl. They all go in there. They're all behaving the same. They can be used in the same linguistic contexts. Why? Because they are the same abstract syntactic category, in this case, the category of noun. That is something you also know. So the process of syntactic categorization, which you've accomplished, is clustering together words that you know behave the same so that you can then use them in the same ways in your language. You also know how to interpret words in context using your knowledge of syntax, which is about the structure of language, and semantics, which is about what things mean. So let's look at this example. So there's a kitty right there, right? Oh, look, a pretty kitty. Look, there's another one. Another what? Well, it could be another pretty kitty, right? Could be maybe just another kitty, right? But it's not another wombat, right? Why not? Well, because you know how to interpret one in this context, and it's really not going to be wombat, right? That's using your knowledge of syntax and semantics. You also know how to put words together into larger phrases and larger units to make, for example, questions, again, using your knowledge of syntax, of language structure. So for example, there's a kitty, and maybe this kitty was bought as a present for someone. Okay, and then there's this girl, Lily, and Lily thinks this kitty is pretty. Great. Now, suppose you want to ask about this situation. Can you ask it this way? Who does Lily think the kitty for is pretty? This should make you scrunch up and be unhappy because you can't ask it this way. I'm going to say it again, and I want you to listen and feel how very bad this sounds. Who does Lily think the kitty for is pretty? You're like, you can't do that. But given this situation, you know what you would want to ask. You cannot ask it that way. That's because of your knowledge of how to put words together to ask questions, which is your knowledge of syntax. You also know how to identify the right interpretation in context using your knowledge of pragmatics. So that's really about how we use language in conversation with each other to communicate. So let's consider this scenario. We have a couple of kitties in these pictures, some of whom are sitting on stairs. That's our world. And here's what I'm going to tell you. Hey, guess what? Every kitty didn't sit on the stairs. What do I mean? Well, there are actually two interpretations to this utterance. One is that no kitties sat on the stairs. That's false in this scenario because some of them are on stairs. The other interpretation is not all kitties sat on stairs, which is true in this world. And so as an adult speaker who understands as part of pragmatics that we like to be cooperative and we like to try to tell the truth, or we assume as a default that other people are telling the truth, we tend to interpret it as not all kitties are sitting on stairs, precisely because that's the interpretation that's true in context. That's using our knowledge of pragmatics. So it's all these different things, among many others that you know when you know your native language, right? So these are just some examples of it. And the question for first language acquisition is simply, how exactly do children learn all of this? It's a lot. So we know that children learn all of this stuff pretty quickly. And that's why it's so interesting. How quickly, you might ask? Well, most of the linguistic system is already known by age 4. Not all of it, but most of it. And that's a lot of stuff to learn when you're really young. So the interesting thing as well is that unlike what we experience in secondary school and formal instruction when we're learning a foreign language, children in their native languages really don't get a lot of explicit instruction about how the language works. And even when they do, and they do occasionally, but even when they do, they don't really pay attention to the things that don't impact meaning, that don't impede their ability to get their message across. So here's an example of this. This is an anecdote that I love from Martin Brain. So this is a child having a conversation with her father about a spoon. So she says, "Want other one spoon, Daddy?" Right? Now, of course, we know that that's not the way you actually say that phrase. And her father realizes this too and says, you mean you want the other spoon, right? He has now explicitly corrected her form of what she's saying. And she is oblivious. "Yes, I want other one spoon, please, Daddy," right? And the father's like, no, let me help you here, my child. Can you say the other spoon? And she's just baffled by this. Other one spoon. Like what? He's like, okay, say other, spoon, spoon, other spoon, other spoon. Now give me other one spoon. Right? So she's completely missed the point of the form correction because, again, it was clear from the beginning that her father knew exactly what she was saying, so her communication ability was not impacted by using the quote-unquote incorrect form for her. So again, this kind of explicit instruction is really not the way that we think children are learning the majority of what they learn about their native language. So how do they do it? Well, what we think they're doing is extracting patterns and making generalizations from the surrounding data in an unsupervised fashion without this kind of correction. And so what they're doing is doing this generalization process just by hearing lots of different examples of what's allowed in the language by native speakers speaking to them and basically giving them lots of data about what is in this language, right? And from that, they figure out all the rules and all the system of their native language. So we can think about this actually as an information processing task. So in particular, given the available input, and the input again is the kind of things that people are saying to kids. So phrases like, "Look at that kitty, there's another one," or, "Where did he hide? What happened?" These kinds of things that you might say, that's your input. And then it's this information processing done by the mind, this process of abstraction and generalization, in order to build a system of linguistic knowledge, all that stuff that we talked about before that you internally know about your language, but we don't see because it's inside your head. And it's the output of that underlying system in your mind that we actually observe. So for example, you saying things like, where's the kitty? Or that one's really cute. Or if someone else says it to you, understanding that appropriately and responding appropriately, right? Comprehension and production. This is the output of that underlying system you've internalized. So to understand how children solve this acquisition task, we need to think more about the components that are actually involved, because this is a complicated process. And so this right here is a framework that I think is helpful for thinking about all the different pieces involved. And so we're going to walk through it because, as you can see, there's a lot of different things going on in it. So first, it distinguishes between things that are external to the child that we can observe, so things like that input signal that they're taking in, and the behavior that they're producing as the output, right? That's external. We can see that. Versus things that are internal to the child, which is everything else that goes on. So one of the first things that goes on is called perceptual encoding. What this is turning that messy, rich input signal into an internal linguistic representation, the perceptual intake, what you are able to take in perceptually at that stage of development. And so this involves using your current knowledge of the language, which we will call the developing grammar. So grammar is just another name for the rules of your language, the system that you internally know about how your language works. Using that, and it's of course developing as you're learning, so using that developing grammar, and you're not just using it, but you're using it in real time as that input is coming in, to parse that input, to break up that input signal into something that you can handle. And you're also relying on extra linguistic systems, that is, systems that are a part of your cognition that aren't specifically used for language. They're used for lots of other stuff, so they are extra linguistic, outside the realm of just language learning. This includes things like working memory, which you use for lots of things, not just language learning. It includes things like auditory processing, which you use for processing all kinds of sounds and not just language sounds. So you use those two, again, in order to turn that input signal into the perceptual intake. So, as an example of perceptual encoding, we can take that rich auditory input signal for speech segmentation, right? That continuous signal that you get that just sounds like a stream of auditory input. And perceptual intake might be turning that into a discrete representation of syllables that have stress on or not on the syllable. You might also encode the speaker identity, like it was mom speaking. You might also be able to tell that some syllables that have stress were more stress than others. They might have one syllable that has main stress and other syllables that have secondary stress. You might also be paying attention to the relative pitch contour, whether it's a high or a mid or a low tone, and that changes over the course of the phrase. So that's the different types of information you might be able to perceptually take in at a particular stage of development from that original auditory input signal. So that was the input side. What about the output side? So one of the other things you need to be able to do is generate observable behavior. So this involves using those current linguistic representations you've taken in from the perceptual intake, as well as your developing grammar, again, your knowledge about how language works, and you gotta feed that into the system that generates that output. So what kind of output does it generate? Well, it can generate both linguistic behavior, like utterances, you might say. It can also generate non-linguistic behavior, right? So if someone says an utterance to you, maybe you look in response to show you understand, or you point, you generate some non-linguistic behavior to indicate your comprehension, right? So these are the behaviors that can be produced. And so these behaviors require both linguistic systems, say of utterance generation, and extra linguistic, non-linguistic systems of, say, motor control or attention or decision-making in order to generate the behavior we actually observe, right? So that's how we get generating observable behavior. Now we've talked about input, we've talked about output. What about the learning part? Well, that's where inference comes in. So inference here, that component talks about the learning. This is how children actually learn from the current data in order to update that developing grammar, that idea about how the language actually works. So what that is you take constraints on hypotheses about how the language works and filters on your attention that you might have as a child at a certain stage of development, and then you concentrate that on the perceptual intake to zoom in on just the part that's relevant for learning at that stage of development. We call that the acquisitional intake, okay? So just to give you a visual example, remember our perceptual intake from before, we had all these different pieces of discrete information like the syllables with stress and the speaker identity and the relative stress and the relative pitch. That's the information you were able to say take in at this stage of development. The acquisitional intake might just be a sequence of syllables with stress, and you ignore all of that other information for the purposes of learning, for the purposes of acquisition and inference at this stage of development. So once you have that acquisitional intake, inference is then going to happen using some of those extra linguistic abilities of update that we have available to us in human cognition. This includes things like statistical learning or probabilistic inference or hypothesis testing, a number of things that we use to change our beliefs about how the world works. We use those on the acquisitional intake in order to generate the most up-to-date ideas about the language's grammar. And that's how inference works. So this whole process happens over and over and over again throughout the entire learning period, which again can extend definitely through age 4, but then sometimes beyond. And just to recap again, the big idea of these pieces, you have the input signal out there in the world, which you are perceptually encoding into a perceptual intake, which is those pieces of that input signal you're capable of perceiving at this stage of development. If we ask you to then produce some behavior because you're responding to something someone said or you want to say something yourself, that's behavior you're going to generate as the output, right? So that's going to involve taking what you're able to perceive and your current developing grammar, your current knowledge about how the language works, feed that through the production systems that allow you to produce that behavior so that you can actually produce it. Then the learning part is that inference part in the corner, right? So that's saying take that perceptual intake, that again, information you were able to take in at this stage of development from the input signal. We're going to filter that down into the section that you think is really relevant at this stage of development for learning from. That's your acquisitional intake. Okay, the intake you use for the purposes of acquisition. And you're going to do update on that. You're going to do some kind of inference to change your hypotheses about how your language works. So you're going to do inference over the acquisitional intake in order to update the developing grammar. And that is really the process that's going to change your ideas about how the grammar, the system of rules for your language, how that works. And again, this is the process that's happening over a period of years throughout early childhood. So from a modeling perspective, an informative computational model of language acquisition is going to capture these important pieces of the process in an empirically grounded way. That is a way connected to what we know right now about how things work in kids. So empirical data about how kids are accomplishing this process of language acquisition. So that involves theoretical analyses of the kinds of representations they might be using, corpus analysis of the kind of data they're hearing and the kind of data they're producing, and then experimental data about what kids are capable of at different stages of development. These are the empirical data we can use to make sure that our computational model is actually a computational model of what kids are doing as best as we can tell. So once we have this, when we have built an informative computational model, it's going to connect the external pieces together. What we know about the input that children are hearing and what we know about the output that they're producing through this pipeline from input to output. And then when we actually have a successful computational model, one that's capable of doing this, it takes in the input that kids get, it produces the output that kids are producing, well then we can look inside it and see what's under the hood. We can see what were the internal pieces that made that possible. And of course, this is the part that's like really hard to do with actual kids. You can't just like open up their heads, right, and see what's inside. But this is exactly what you can do when you have a computational model of the acquisition process, and why it's really useful for us as cognitive scientists to figure out what's going on with respect to language development. So with computational modeling, we can understand more precisely how the learning strategies that children are using to accomplish language acquisition work. So let me tell you about some things we've learned by model building this way. And we're going to focus on the area of speech segmentation, which again is that process of taking a continuous auditory signal, which has all of this information in it, which again visually is represented in the graph over there. And it's that process of turning it into an internal, discrete representation, which we consciously perceive as a sequence of words, like "what a pretty kitty." Okay, so let's focus on that task. So recently in my lab, we've investigated a certain type of learning strategy for the very early stages of speech segmentation that occur around 6 months of age, so little tiny babies, right? And the particular type of strategy uses something called Bayesian inference, which is represented by that equation down there in the corner. So what I want to do is give you the intuition of what that's doing. So the intuition of Bayesian inference as applied in this case to speech segmentation. So the idea, you're a little tiny baby and you get this fluent stream of speech and you're trying to find the best segmentation, the best way to break up that fluent stream of speech. So the best answer, the best segmentation S, is going to be based on the utterance that you just heard, U. So that's that first term, the probability of your answer given the utterance you just heard. That depends on two things. The first thing is your prior beliefs about what good answers look like. Maybe you have some ideas that good answers look like this, or good answers don't look like that, right? That's part of what you're folding into your decision about what the right answer is. And the second thing is that you want whatever answer you're considering to be able to explain the data you actually heard. You must be able to match it, must be able to account for it. So you're balancing these two things, your prior beliefs about what a good answer looks like and the fit of that answer to the actual data you observed. That's Bayesian inference. And so combining those two things together is how you make your decision about what the right answer is. And so that's the kind of strategy we wanted to see if infants were using at this age. So the particular strategy was that, okay, we want you to identify a list of word forms called a lexicon that best accounts or generates the utterance you actually heard of fluent speech. So here are three example little teeny mini lexicons. You can see there are a list of word forms which are actually written in the International Phonetic Alphabet, which is why they don't look like words you recognize. But the idea is they're just a list of word forms, right? That if you put them together, will actually match the utterance you just heard, will be that segmented stream of speech. Here are three possibilities. And so this strategy has prior beliefs about what good answers look like. And so it mathematically encoded two preferences. The first one was a preference to prefer shorter words. So if you look at these three lexicon options, that first one has the shortest words, right? So this preference would bias you towards that answer as the right one. The other preference was to prefer fewer words. So that's going to actually bias you towards the third option because that one only has 2 word forms while the other ones have 3. So these preferences are kind of in conflict, right? You want to balance those already in your ideas about what the right answer might be. Those are the prior beliefs that our model children were working with. So the idea from a Bayesian inference standpoint, again, we're trying to find the best answer, the best segmentation, that's going to balance these preferences, the preference for shorter words, the preference for fewer words, right? And also matches the observable data, right? You got to be able to actually account for the speech that you just heard. And that's the intuition of how this strategy works. And so we implemented this in a number of different models of the type I told you about before that were grounded empirically with theory, with corpus methods, and with experimental data. And the first question we wanted to answer was, okay, seems like a very exciting strategy. Is it actually useful for children, right? If you take children's input, can it generate a good output, right? Like, is it even useful to do this? It seems like a good idea, but we should probably find out if it is a good idea. So we modeled learners that didn't have any cognitive limitations on their inference or memory, and we wanted to see how they did. And it turns out they do really well, right? So if we give them realistic English child-directed speech, the kind of input that little English 6-month-olds are getting, they're able to segment using this strategy pretty darn well. Now, the inferred lexicons aren't perfect, but then you might not think that 6-month-olds have perfect segmentation. In fact, empirically, we know from experimental data that they don't, right? But the lexicon that they inferred, the answers that these modeled learners arrived at were really good ones because they were useful for subsequent stages of acquisition that depend on the output of this segmentation process. So the upshot is that this is a really useful learning strategy for 6-month-olds to use. So then the question is, okay, so it's great that it's useful. Is it usable by actual 6-month-olds? Because remember, 6-month-olds, hey, guess what? They do have limitations on their memory. They do have limitations on their cognitive resources. So what if we model learners that have the same kind of restrictions? Can they still use this strategy? And the answer is yes. Modeled learners with cognitive limitations on their inference and their memory can use this Bayesian inference strategy and still segment English quite well, right? So that tells us that this is a strategy that's usable by children, by little 6-month-olds. Now, you'll notice I've been talking about English data. So you might be wondering, great, but there are other languages out there in this world. Does this strategy work when we test it on different language data? So it turns out, yes, it does. It turns out it segments really well for languages that have quite different linguistic properties. So they have different morphology, which is the way you put word pieces together. They have different syllable properties. So some have many, many different types of syllables. Some only have a few syllable types. And so the languages we tested were Spanish and Italian, German, Hungarian, Japanese, and Farsi. It works great on all of them. So, hey, it does work well for a variety of different languages. So the takeaway from this is that, hey, this kind of strategy that relies on this Bayesian inference decision-making seems to be a really good one for the kinds of things very young babies at 6 months might be using to begin to segment the languages that they're learning. Okay, so let's recap. So what I've tried to tell you, or hopefully convince you, is that language acquisition is a really interesting area of research in human cognition. Why? Because it's really hard. There's a lot of different stuff you've got to figure out, and you've got to figure it out fast, and we're not really sure how you do it, right? So it's hard and therefore interesting. And little humans are really good at it, right? And that's surprising. Little humans are not good at a lot of stuff, but they're good at this, right? So that makes it a very interesting area of research in human cognition. So to understand how this process works, what we can do is build cognitive computational models that capture the important components of the language acquisition process. And then when they work, we can look inside them and see exactly how it is that they work, why they work. So by model building this way, we have found that, for example, for the process of speech segmentation, which is dividing a fluent stream of speech up into useful pieces, a strategy that relies on Bayesian inference seems to be a really good idea. It's a plausible learning strategy that's useful for kids, usable by little tiny kids, and something that works well for a lot of different languages. So thank you so much for watching. Again, my name is Lisa Pearl, and I'm an associate professor at UCIrvine in the departments of linguistics and cognitive sciences. I run the Computational Language Laboratory, and we have a webpage which you should check out to see all of our exciting projects in this area. I also have a teaching subsection of my webpage that has courses on these topics, that has podcasts that you can watch, and you should feel free to watch on these topics. Even if you're not enrolled in the courses, you can see them. And you should also feel free to contact me if you have any questions. I love to talk about this stuff, as I hope you can tell, and I would love to talk about it with you. Thank you.